The moment a software company starts building its own chips, you are no longer looking at a software company. OpenAI just unveiled its first custom silicon, developed through a deal with Broadcom, explicitly framing the move as an effort to, quote, build the full stack. That phrase, full stack, is doing an enormous amount of work. Because the question it opens is this: if OpenAI controls its own chips, its own models, and its own deployment infrastructure, what exactly does that leave for every other company currently sitting in that value chain? That answer has real consequences for where money flows in this industry. Let's be precise about what is actually happening here, because the narrative around AI companies building custom silicon gets muddled fast. OpenAI has unveiled its first chip developed in partnership with Broadcom. The explicit stated goal is to build the full stack, meaning OpenAI wants to own as many layers of its own infrastructure as possible, from model architecture down to the hardware running inference. This is not an unusual ambition. Google did it with TPUs, Amazon did it with Trainium and Inferentia, Apple did it with the M-series. Every major technology company that reaches sufficient scale eventually confronts the same math. Buying compute from someone else at scale is expensive, and it hands pricing power to your supplier. For OpenAI, that supplier has been NVIDIA. The H100 and now the Blackwell generation have been the backbone of large language model training and inference across the industry. When you are running one of the most computationally intensive workloads in the history of commercial software, your chip bill is not a rounding error. It is a defining cost structure. Building your own silicon does not eliminate that cost immediately. Custom chip programs take years and significant capital before they generate returns. The Broadcom partnership matters here. Broadcom has deep expertise in custom ASIC design and the manufacturing relationships to bring a design to production scale. OpenAI is not trying to out-engineer NVIDIA on raw training performance. The more likely play, based on what we know from comparable programs, is optimizing for inference efficiency, meaning running deployed models cheaper at scale for the hundreds of millions of users already in the product. That is where the economics are sharpest right now. The actionable insight: vertical integration in AI infrastructure is accelerating, and it compresses margin for every pure-play hardware or cloud vendor sitting between an AI lab and its end users. OpenAI's chip announcement does not exist in isolation. Look at what else is moving in the same 24-hour window in June 2026. SK Hynix, South Korea's largest chip maker and the dominant producer of high-bandwidth memory, the memory architecture that makes modern AI accelerators function, is planning a $29 billion NASDAQ listing as soon as July 10th. To be clear about the scale, $29 billion is one of the largest listings on any exchange in recent memory. SK Hynix supplies the HBM that goes into NVIDIA's GPUs. This listing is not a company celebrating its current position. It is a company raising capital to build capacity for a demand curve it believes is going substantially higher. Meanwhile, Qualcomm has acquired Modular, an AI software startup focused on next-generation compiler infrastructure and data center software stacks. Qualcomm's traditional strength is mobile silicon, Snapdragon chips, and smartphones. But the company has been methodically repositioning toward AI inference at the edge and now at the data center level. The Modular acquisition is about software-hardware co-design, making Qualcomm's silicon more programmable and accessible for AI workloads without requiring engineers to write low-level code for each chip architecture. Here is what these three moves have in common. Every major player is trying to reduce its dependency on adjacent layers of the stack. OpenAI wants to own its silicon. Qualcomm wants to own the software that makes its silicon useful. SK Hynix wants the capital to own more of the memory supply chain. The architecture of the AI industry is consolidating vertically, not expanding horizontally. Companies that are pure-play providers of one layer, just cloud compute, just memory, just software tooling, face increasing pressure as their largest customers become their largest competitors. That dynamic is worth tracking closely, regardless of your specific exposure to this space. There is a fourth story running parallel to all of this, and it may ultimately reshape the economics of AI infrastructure more than any chip announcement. A bill is currently moving through Congress in 2026 that would require technology companies to pay the energy costs associated with AI data centers. This is worth unpacking carefully, because the framing matters. Right now, AI data centers draw power from regional grids. In many cases, the cost of upgrading that grid infrastructure, new transmission lines, substation upgrades, additional generation capacity, is socialized across ratepayers in that region. Ordinary electricity customers effectively subsidize the power needs of hyperscale data centers through higher baseline rates and infrastructure investment absorbed by utilities. The proposed legislation would shift that burden back onto the technology companies operating those facilities. This is not financial advice, and the bill's final form and passage are far from certain. But the directional logic is worth thinking through analytically. AI data centers are extraordinarily power-intensive. A large GPU cluster running at full utilization consumes power at a scale comparable to a small city. If technology companies bear the full cost of the energy infrastructure required to run AI at scale, that changes the capital expenditure math significantly. It also creates a geographic arbitrage incentive. Companies would have stronger financial motivation to locate data centers near low-cost, high-capacity power sources, whether that is hydroelectric regions, nuclear facilities, or areas with excess renewable generation. This has second-order effects on real estate markets, utility company valuations, and the competitive dynamics between cloud providers who own their infrastructure versus those who lease it. The companies best positioned in a world where energy costs are internalized are those with the deepest balance sheets and the most efficient custom silicon, which circles back precisely to why OpenAI is building its own chip in the first place. The full-stack ambition is also, at its core, an energy efficiency play. We opened by asking what it actually means when a software company builds its own chip. The answer is that it's rarely just about the chip. It is about removing every external constraint on cost, performance, and scale. OpenAI's Broadcom deal, SK Hynix's $29 billion raise, Qualcomm's modular acquisition, and a congressional energy bill are all the same story told from 4 different angles. Vertical integration is rewriting the AI value chain in real time. The follow-up question worth sitting with: if the labs own the silicon and the energy costs get internalized, what is the durable moat for the cloud providers? Subscribe to Synthetic Alpha. We will get into that next.